Assalamu alaikum wa rahmatullah. Good day, everyone, and welcome back to our physics class. In today's physics class, we will solve problem 3, the third problem under the section problem solving on electric current. Okay, let's read the problem. When the current density in a conductor is 1.20 times 10 raised to the power of 6 amperes per square meter, uh, the drift velocity of the conduction electron is 1.2 times 10 raised to the power of minus 6 meters per second. Okay, what is the number density, meaning number per unit volume of the conduction electrons, and the elementary charge is given as 1.60 times 10 raised to the power of negative 19 coulomb. Okay, we are going to bring out the parameters we are given and identify the target variable. Then we will decide which formula is relevant here. Okay, when the current density, remember we say current density is when you divide the magnitude of current by the cross-sectional area. Current divided by cross-sectional area, current in ampere divided by area in meter square meter. And this is why you see we have ampere per square meter, because current density is J and J is I over A. So this I, current, is in ampere, cross-sectional area is in square meter. When you combine these two units, you have ampere per square meter. So this is why we have the unit here in ampere per square meter. So I'm saying that this is our J. Okay, this is our current density J. The drift velocity of the conduction electron is this. The free electrons that move about within the conductor, they have this drift velocity. So this is our drift velocity in meters per second and is given later V. Okay, what is the number density? Okay, this number density, it has many names. In some books they call it number density, in others they call it charge carrier density. Okay, and they mean one and the same thing. The number of free electrons per unit volume of the material. Every 1 meter cube volume of the material, if you add the number of free electrons generating electric current there, that number is what we call number density or charge carrier density. And we give it small letter n. Okay, the unit is per cubic meter. Then elementary charge is this is E, right? It's a constant. Whether it's given or not, we know that it's always this. Okay, um this n is our target variable. Okay, after identifying the parameters given in the problem, I say we will identify the target variable, what we are asked to find. And what we are asked to find or calculate is the number density. Okay, next we look for a formula that relates all of them together. We will start with the formula for current density. Current density J, the magnitude is I upon A. But this is not enough, because in this one we don't have N. We don't have N. Okay, we don't have N. In fact, we don't even have the drift velocity. So we are going to bring the other formula by recording that I is NAVE. So instead of I here, we can put NAVE and then divided by this E, so that our E here, the cross-sectional area, cancels. Thank God, because we are not given cross-sectional area anywhere here, so we don't need it. Interestingly, it is cancelled here. This is equal to, then I have NVE. So this means instead of using J is equal to I upon A, I can simply use J is equal to NVE. is my target variable. So I will make n the subject of the formula. Now, to do that, I will simply say my n is equal to, I will say j divided by everything here except m. So if we exclude n, I have v and e, so we have v, e here. The next is substitution. Let's do it here. N is equal to, what is our j? Our j is here. We identified it. 1.20 times 10 raised to the power of 6 times 10 raised to the power of 6. You see? And then divided by v. What is v? Our v is this 1.2 times 10 raised to the power of minus 4. 1.2 times 10 raised to the power of minus 4. Well, let's open brackets here since we have more than one parameter in the denominator. E is the elementary charge and is this one. Okay, this is our E, the elementary charge. And we have to multiply it because they say V times E. So times 1.60 times 10 raised to the power of negative 19. Okay. Finally, we bring our calculator. So we say we start with the numerator here. The numerator is 1.20. See, so we say 1.20 exponential 6. The 6 has no negative attached to it. So next we say divided by, then we open bracket 1.2 exponential, we press exponential, the negative, look at the negative here, we press negative 4 times 1.6 exponential negative 19. Now close the bracket. After closing the bracket, you can now press this function to get the result. And our result is 6 point, you see, it is 6.25 times 10 raised to the power of 28. So we write that 6.25 times 10 raised to the power of 28. The unit of n is per cubic meter. Okay. Now, what is the physical interpretation of this? It means that in 1 cubic meter volume of the material, you have 6.28 times 25 times 10 raised to the power of 28 free electrons that generate electric current in that region. Okay, every 1 cubic meter volume has this number of free electrons, excluding the electrons that participate in bonding. No, not that. Only free electrons, because these are responsible for generating electric current. Okay, how do I know whether my n is correct or not? Okay, your n is usually a large value. The power of 10 here is number 1 positive, and number 2 is a large value. If at the end of the day you just got 6.25 times 10 to the power of 5 or 3 or 2, you know that it can't be right. N is extremely large, and you can see 28 is a large value, is a large power for 10. So if you get a negative power here, minus 28, you know it can't be right. Okay, it can't be right. It's not, this means that you don't have even up to 1 electron, because times 10 to the power minus 28 means you have 0.0000028 zeros before you have 625, which is much less than 1. So it means that in 1 cubic meter volume you have much less than 1 electron. This is inconceivable. This is physically inadmissible, unacceptable. Okay? It doesn't make sense at all. It is contrary to reason. Okay? So I'm saying your n has to be large. Don't forget that. If it is not large, go back to the process of calculation. Maybe you did not press one or two functions right. Okay, or maybe you did not use the right formula, or somewhere there has to be conversion and you didn't make the conversion. Always check your result. Okay, don't just find the result after finding the result, you just underline it and say, oh, I got the answer, without thinking about your result, whether it makes sense or not. Okay, there has to be critical thinking at the end of it. Okay, this is all that we have today, and I thank you all for watching. Assalamu alaikum wa rahmatullah.